Yesterday we defined kinematics as the study of motion without regard to what causes the motion. You guys told me yesterday what it is that causes motion. What was it? Forces, right? Forces cause motion. So in this unit, we're going to talk about motion, but we're not going to pay any attention to forces that cause the motion. In fact, this may be the last time we mention the word force in this unit. In our next unit, we're going to talk a lot about forces because we're going to be paying attention to what causes the motion. But now it's just the motion itself. Two more terms, vector and a scalar. One of them has just magnitude or an amount. Which one is that, vector or scalar? Scalar has just magnitude. That means vector has both magnitude and direction, just like in Despicable Me. You guys remember? How many people have seen that movie? Vector, when he's going to the bank to get his money, he says, I'm vector, both magnitude and direction. You guys remember that? No? You should go back and watch that movie this weekend. So a vector has both magnitude and direction. Scalar has just magnitude. We learned three terms yesterday that are examples of vectors or scalars. Distance is a vector or scalar. Distance is a scalar because it doesn't require direction. Position is a vector, and displacement is a vector. Distance we defined loosely as how far something's traveled. It's how far something's traveling or how far something has traveled. Do you guys remember the symbol for distance? Yeah, occasionally we could say d, but usually we're going to say delta d there. The reason that there are two possibilities for that is because you could say the distance between Adam and Riley is 1 meter, and that's really a d, because nothing's going that distance, right? But when we talk in physics about distance, we're usually talking about something's gone over that distance. So that would be a delta d because there's a change involved there. Does that make sense? So could be d, but it's almost always, for us at least, going to be delta d, and that's why I'm writing it down as delta d, the change there. Units are, the standard units at least, meters. We saw yesterday in some of the examples we did kilometers, right? Sometimes you can use kilometers or any units you want, but you can't always. If in doubt, you should go with meters because meters always works for you. Listen, when we get to a situation where you have to use meters, I'll point it out. But if you're ever not sure, just use meters because it always works for you. Okay, position is defined as where something is at a specific moment in time, where Riley is, or where Janae is, or where Brogan is at this moment in time, or some other moment in time. The symbol for position is, anyone? Ireland, the symbol for position? No? D with an arrow over it, good. The little arrow means what? It's a little half arrow, by the way. Although if you put a full arrow, I would mark that wrong. Yeah. No, the arrow doesn't mean change. Good, it means direction. It means it's a vector, right? If I put a delta in front of it, it would mean a change. Why isn't there a delta in front of that? Why isn't it delta D? Why am I not talking about a change here? Yep. Yeah, position, like the position is where you are right now or some other time, not where you go over a period of time. Right, Taylor, is that pretty much what you're going to say there? Good. Units, Taylor, what are the units for position? Yeah, the standard units are meters, although sometimes we can use others. Displacement is, I'm going to ask you to define that one for me again. Rachel, displacement? Good. What the position is changed by. So if Brogan was 1 meter south of the back wall, and then her position is 4 meters south of the back wall, her change in position is 3 meters to the south. Okay? That's going to be a symbol of, what's it going to look like there? Yep. Good. Delta D with the triangle over it. Delta because it's a change, and D with the arrow over it because it's a vector. Direction matters here. And the units are, anybody for this one? Just tell me. Meters. Yeah, the standard units at least. Okay, we learned to calculate displacement in two ways yesterday. It depended upon what we were given. If we were given positions, a couple of different positions, then to find displacement, we would do what? So Brogan was, the example I think I had was, Brogan was 1 meter south of the front of the room, or of the back of the room. And then she's 4 meters south of the back of the room. What do I do with those two numbers to find her displacement? Subtract them, right? When you have two different positions, we subtract them. It's the final position minus the initial position. And if we're given two different displacements, so similar scenario, but let's change it around a little bit. Brogan walked 1 meter south, and then she walked 4 meters south. Those are two different displacements, right? How do we find the total displacement then? We add them together, right? So it would be delta D is equal to negative 1 meter because it's south, plus negative 4 meters because it was south. We make sure we add them together. Although we do have to put in negatives sometimes, so sometimes it looks like we're subtracting, and mathematically we kind of are, but we think of it as an adding thing. Make sense? Okay. Yesterday we were working on some questions on worksheet number 1, and I want to take a look at one or two of these right now before I let you finish off that worksheet. Which one or two would you like to take a look at? Just first come, first serve here. Whoever points out the one that gave them the most trouble is the one that we end up doing here. 7 it is. Oh yeah, I could see that one giving you trouble. I would almost say that might be the hardest one on the page, actually. 7. A boy walks 100 meters north, then 200 meters east, then 50 meters to the south, and then 200 meters to the west, and then 50 meters to the south. What's his distance traveled? What's his displacement? Firstly, what do we have given to us? He walks 100 meters north, 200 meters east. Are those positions or are those displacements? Are those where he is at specific moments or how far he's gone? Positions or displacements? Yes. The problem is that he's got so many of them and that we've got north, south, east, and west, like 2 dimensions here. Right now, this has to be a really specific case of this, because if it wasn't this specific case, you couldn't do it right now. Later on, it doesn't matter what those numbers are, you'll be able to do it. But right now, if it's not these numbers or close, you wouldn't be able to do this. You'll see why in a second here. Let's look at 100 meters to the north, 50 south, 50 south. What's my total displacement north-south? 0. 200 meters east, 200 meters west. What's my total displacement east-west? 0. So what's my displacement? This is like that question where we had a person makes 2 laps around the 400-meter track. The distance traveled was 800. The displacement was 0. It doesn't matter how that person got back to where he or she started. We're back to where we started. My displacement is 0. Now, if the blues didn't cancel each other and the greens didn't cancel each other, right now we'd be kind of hooped. Okay? But they do. So we're okay with that question. The displacement ends up being 0. If we got a multi-dimensional thing like this, right now, it pretty much has to be 0 for displacement because you have no other way of figuring it out. So let's do B first. Let's say the displacement is 0 because all the blues cancel and all the greens cancel back to where I started. It's my distance traveled. Distance is the easier one here. I'm not going to suggest that it's easy, but it's easier. Anybody want to tell me help us out how to find the distance? That many? Yeah. How'd you do that? Yeah. 100 meters plus 200 plus 50 plus 200 plus 50. Why didn't you pay any attention to the north and the east and the south and the west? because distance is a scalar. So that's like when you ran around that track two times, your distance was 800 meters, regardless of which way you were going, but your displacement was 0 because you ended up where you started. Okay? That okay? Does that make sense? All right. You guys want to do another one? Are you okay? Okay, I'm going to give you a few minutes then to finish this up, questions 8 and 9, or any of the other ones if you haven't finished those yet. And then we'll take a look at a couple of those in a moment here. So we're going to have a look at number 8 now. It says, a man begins driving his car 50 kilometers east of Banff. Notice we're using kilometers. Said the standard units are meters. We're allowed to use kilometers here. That's fine. Okay, there's certain times when we have to use meters, but I told you I'll fill you in on when that is, when it happens. He begins driving his car 50 kilometers east of Banff. A while later, the man and his car are 300 kilometers east of Banff. Even later, they're 400 kilometers east of Banff. Those are positions, right? Those are where the man and his car are at specific moments of time, not how far he's gone. It doesn't say anywhere here that he's driven his car 50 kilometers, then 300, then 400. He's here, then he's there, and then he's over there. 3 different positions. I'm going to calculate B first, the displacement. I think it's easier. When I want to find displacement given positions, I always say df minus di, my final minus initial position. What's my final position here? 400 kilometers east of Banff. I'm going to make east positive, and therefore df will be positive 400 kilometers. What's di? Ooh, 50 or 300? 50. We get an answer here of 350 kilometers, which means east because it's positive. Where does the 300 kilometers come into play here? It doesn't. Now, that can be a little bit confusing, right? We're given a number that doesn't make any difference. Like, let's think about this, though. Okay, the man started at 50 kilometers east of Banff. He ended at 400 kilometers east of Banff. Of course, he's going to be at some point 300 kilometers east of Banff. You know what? He's also going to be 232.9 kilometers east of Banff, but we didn't care about that number. He's going to be every number in between 50 and 400. Like, he's going to be in all those positions at some point. But do all those numbers matter? No, if we have the initial and final position, what matters? The initial and final position, not all the infinite number of numbers that are in between the initial and final. Does that make sense? How many people were trying to think, how can I use that 300? Like, I don't know. If I was in your spot, I'd probably be trying to do that. But understand that if we've got positions, we subtract final minus initial, and what's in between doesn't matter. Okay? Now, what's the distance traveled by the man? Distance traveled is 300. How come it's the same value? Sorry, 350, I should say. That's 300 is not the same value. 350 is the correct answer, and it's the same value. How come it's the same number? Minus the direction. Because we're going the same way. He hasn't changed direction. Okay. If you take a look at number 9, and I won't go over that one quite yet with you, but if you take a look at that one, what's different about that besides the numbers? What's different about number 9? Yeah, Janae? Yeah, so he does change direction, right? He's driving to the east, and then he turns around and goes west. So he goes back towards Banff. Okay, see what you can do with number 9, and we'll give you 2 or 3 more minutes to do that, and then we'll take a look at that one as a group, okay? Okay, let's have a look at number 9 now. It says, similar to number 8, it says a man begins driving his car 50 kilometers east of Banff. While later, the man in his car is 300 kilometers east of Banff. Even later, we're 150 kilometers east of Banff. So in this case, unlike number 8, we're driving away from Banff, and then we turn around and go back towards Banff. Now, that doesn't change how we're going to find the displacement. Okay, the displacement is final position minus initial position. and we're given 3 positions here. That's okay. We don't really care where we went in between the initial and final in order to get displacement. All we care about there is what my initial and my final is. My final is 150 kilometers east of Banff. My initial is 50 kilometers east of Banff. So we're going to say my displacement is simply 100 kilometers, or positive 100 means 100 to the east of Banff. I end up 100 kilometers east of where I started, east of Banff. Now, the distance is a little bit tougher here. Because we change direction, the distance is not the same as the displacement. So it's not 100. Anybody have an answer that they think might be right? Anybody have a method that they used? Yeah, Rachel? 400? How'd you do that? Okay, so you're saying when he went from 50 to 300, he moved 250 kilometers. Okay? Okay, good, good. That's exactly what I would do as well. So essentially what you're doing is a couple different stages here. You're finding the displacement or the distance in the first stage. From 50 to 300, he went 250 kilometers, technically to the east, right? Although it doesn't really matter for distance. In the second stage, he went, well, from 300 to 150, which is technically negative 150 for a displacement, right? And if I want to add those displacements together to get a total displacement, guess what I get? 100. But if I add the magnitudes to get distance, I'm going to get 400 kilometers, right? Good there? Okay, so here's what's going to happen on Tuesday. Here's what's going to happen on Wednesday. On Wednesday, we're going to have a little quiz on this stuff. But on Tuesday, we're going to have ourselves a little practice quiz on this stuff. Okay, so the practice quiz is going to look pretty much like the quiz, except it's not going to count. We're not going to do that every time. Sometimes we will, sometimes we won't. But this time, especially since it's the first one, we will. Treat it as if it's a real quiz. I don't expect you to study for 3 hours this weekend. 2.5 is fine. Probably not even 2.5 hours. But pretend Tuesdays is a real quiz. Do what you can. Try to get 100. Okay, then Wednesday should be really, really easy, right? But if you do happen to mess up on a little bit on Tuesday's quiz, hopefully we can fix that before we have our real quiz on Wednesday. Make sense?